Today, the subject that I'm going to talk on is basic ventilation in our poultry industry. So there will be a quick presentation that I will work with you on. So basically, as we wait for the presentation to come on the screen, see, poultry ventilation is a subject that has been very close to my heart from the very beginning. I feel that it is not a very complicated subject, but somehow we as an industry, as a collective, as an industry have made it very, very complicated. So my attempt today is going to be to break it down so that we don't feel intimidated by it and we feel that it is something that we can deal with quite easily. So chickens, as we all know, are homeothermic animals. They basically have internal mechanisms with which they can control their own temperature. But this only works in certain conditions. If it gets too hot or if it gets too cold, then basically they go under stress. As we all know, especially in the colder conditions, they have feathers which they can always use to regulate their body temperature. But let's now focus on what happens when it gets very hot. So birds don't have, we as human beings, we know that we sweat, but birds don't have sweat glands, as we know. So generally what they do is they have a mechanism which is basically panting. So panting, what it does is they swallow the air which is supposed to be colder than their internal body temperature, and this cold air goes inside, and as they bring it out through the water water in their in the system, basically they are going to cool this air down and bring their body temperatures down. This is the mechanism that is inbuilt in birds to help them to cool down. So this mechanism is something basically, as we said in the earlier slide, has limitations. So there are two ways in which the birds can naturally lose heat. The first one is called latent heat loss. So basically that is related to water vapor. In this, the moisture that is basically referred to as moisture production. Evaporation uses broiler heat to change water state from liquid to vapor. The evaporation takes place inside the broiler as water passes over the wet surface in its respiratory system. And the second one is sensible heat loss. Basically heat loss through feathers, through body heat. So when the outside air temperature is cooler and the body temperature is warmer, they can transfer heat from their body into the air surrounding them. So basically if we consider all this, it is very important for us to understand that birds have to be housed and cared for in an environment which will enable them to use their internal mechanisms and to maintain a thermal balance. This is known as a thermoneutral zone. This is a range in which the temperature of the animal does not have to basically they don't have to, what is going to happen is if the temperature is too hot or too cold, what basically happens is they have to use these mechanisms a lot. They have to burn a lot of calories, for example, to maintain their body temperatures. So when we talk about cold, it is relatively easy. We don't have that many problems when it comes to India, when it comes to cold weather. Actually, anywhere in the world, it's very easy to increase the temperature of the house. And body temperature wise also, birds have a lot more flexibility when it comes to maintaining cold weather related stress. So as we can see, the body temperature of a bird can go as low as 22.7 degrees Celsius before death can occur because of cold. But on the upper limit, the limit is not much. The bird's body temperature is around 41 degrees Celsius, but at around 45 to 47, death can occur due to heat-related stress. So basically for overall well-being and improved performance, it is important to ensure that birds are always in their thermoneutral zone. So for grown-up birds, this is around 25 degrees Celsius at about 65% or 70% relative humidity. The body temperature of a bird is around 39-40 degrees Celsius For human beings, it's about 5 degrees lesser. We are about 36, 37 degrees Celsius. So if you give them 25 degrees Celsius at around 65 to 70% relative humidity, your birds are going to be very, very comfortable and your productivity is going to be significantly higher. So we spoke about thermoneutral zone. So this is what I'm talking about. So in the thermoneutral zone, as you can see, there is a certain temperature and relative humidity at which the birds are going to give you optimum performance. If it starts getting too cold or if it starts getting too hot, your birds are going to go in under stress. If it goes too hot, birds stop eating and there can be heat related stress. If the temperature goes too cold, the birds eat excess or they will start burning their, instead of gaining weight or producing eggs, they will want to produce heat, so they will burn calories for that. So this is the challenging part. What we have looked so far is basically what are the challenges, right? So now we are sitting in Namakkal, or this can be replicated in many, many pockets, poultry pockets of India. So sometimes what we don't understand is we focus too much on temperature, and this is, I think, where most of us make the mistake on getting efficiency in poultry housing. The relative humidity is a very important factor that we have to consider when we are talking about temperature. What we are basically giving as evaporative cooling systems, EC houses, environmentally controlled systems, these are water-based cooling systems. And when we talk about water-based cooling systems, one thing that we have to understand is we are using water to cool down the air inside the poultry house. Now this is directly related to the amount of humidity that exists in the air. So what is this amount of humidity that exists in the air? This is calculated by using the term relative humidity. So relative humidity is a term commonly used to describe how much water vapor is in the air as a percentage. Saturated air at 100% relative humidity will not be able to absorb any more heat loss through water vapor. Air with 50% humidity will contain 50% capacity for it to absorb heat loss through water vapor. So that's the basic principle in all of this. So let us see this example that we have. So we have one where the relative humidity is 0, 150%, 175, and 100. So as we saw a little while earlier about the kind of heat losses. So we spoke about latent heat loss. So this is the most important part. So in the latent heat loss, what is going to happen is if you have no humidity, that means the capacity of air to basically absorb the heat and cool the environment in the house down is at 100% capacity. And as your relative humidity starts going up and up and up, the capacity of this air to absorb excess heat is going to drop significantly. So this is a very, very big factor in air conditioning. We don't have this issue, but in evaporative cooling system, this becomes a major issue. And if we don't consider that, then your EC houses are not going to function the way they are supposed to function. So as we stated before, the birds are homeothermic. They produce and dissipate heat to maintain a relatively constant body temperature. Based on the incoming air temperature, the amount of air required to keep the bird in its thermoneutral zone is always going to change. So this is not just the temperature of the air, but also the relative humidity in its surrounding. As the temperature increases, the amount of air changes will also increase to take away the heat produced by the birds and to keep them in their thermoneutral zone. So basically, if you now correlate this to the slide earlier, what effectively we are saying is, as the temperature and the relative humidity goes up, your air speed should correspondingly be going up as well. If this is not happening in the correct fashion, then no matter what you do, you are not going to get the right kind of environment inside the house. Let's talk about what is the amount of air that you require. Now this is a basic formula that you need to consider. We have taken a very typical broiler house with 25,000 birds of 2 kilos each. Let us say the length is around 420 feet by 45 feet wide and 8 feet side height. So in this house, Let us consider this chart, the outside temperature being 15, 20, 25, 30 and 35, and the CMH required. Now this is a basic calculation that we can of course sit and we can tell you why this calculation has happened. So this calculation comes in. So this is per kg is what is required. So as you can see, the total cubic meters of air exchange per hour keeps changing as the temperature outside starts going up. So this is very, very important. So that will tell you what is the total CMH required. I'll tell you total amount of cubic meters per second of air that needs to be exchanged, and the velocity per meter inside the house at which the fans need to work. Now of course this can be done two ways. One way to do it is to have multiple stages, and the other way to do it is to have a variable frequency drive where the fan speed keeps increasing. The principle is the same, but this is what is, as you can see. So as it becomes very hot, let us say 35 degrees Celsius and above, and probably at that time the humidity is going to be 80-85%, we require a minimum of 3.2, I would say even 3.5 meters per second of air velocity inside the house for you to get good results in an EC house. If this is not being achieved, no matter what you do, just running your cooling pads is just going to add to your problems and not going to solve your problems. So this is a photo that if you go with a thermal camera inside a house, literally chickens are like, you know, they are like little balls of fire. This is how it looks. That is the amount of heat that is being dissipated from a bird. And you know, we spoke about this poultry industry. In the last 50 years, we have gone from chickens becoming 2 kilos in about 2.5 months to now chickens we are achieving 2 kilos of body weight in under 4 weeks. So that is so basically the amount of heat generated has gone from the same amount of heat generated over 2.5 months to 25 days. So it is a very intensive kind of heat loss that we are experiencing in the same kind of a house. So for that, environmental control is becoming more and more important. In fact, it has become hypercritical today. So, as I said, under normal temperature, normal conditions is not a problem, but in our country, in India, we don't get normal conditions for 8 months out of 12. No matter where you go, we always have this issue. So, I totally agree that air temperature is going to represent a big part, but again, because we are not using air conditioning and we are using evaporative cooling, the humidity has to be considered when we do any kind of heat loss that we have to achieve inside a poultry house. So yeah, so it's a very simple, it's very simple, it is not very complicated. What do we have to do? We have to design a proper environmental control system, proper amount of air velocity has to be considered, the right amount of cooling pads have to be considered, but the house is also very, very important. The insulation of the house is extremely important when it comes to evaporative controlled houses. The reason is because heat is not just coming from the birds, but the heat is also coming in from the house itself. And this sometimes we don't consider. We put the best kind of fans, we put the best kind of controllers, but through the roof, through the side walls, through the curtains, you have heat coming in or heat being lost, which is a major issue. So in this, as you can see, the amount of air exchange to control temperature depends on the indoor and outdoor temperature difference, the number and age of the broilers or the layers for that matter, and the building insulation level. If the sensible heat loss remains constant, reducing the amount of air exchange will raise the indoor air temperature. Increasing the air exchange will lower the indoor temperature. If the air exchange and sensible heat loss sources are kept constant, the indoor temperature will shadow the outside temperature changes. Now that is very, very important. See, the sensible heat loss source apart from the birds is your house. So in EC houses today, one of the factors that we need to, the old style brick and mortar kind of houses are good conductors of heat. So they are not going to help you when you have so much heat that we have to dissipate inside the house in such a short time. So this is, housing is a very, very important part of a correct EC house. In hot and humid weather, Heat stress can be a problem because chickens have difficulty getting rid of their body heat. That's what we said earlier, right? When there is already a lot of moisture inside in the air, this becomes a major challenge for the birds to lose latent heat. So ventilation is an important factor to remove litter moisture control. Ventilation air exchange is used to remove moisture produced within the building. Excessive air exchange can remove too much moisture and produce dry and dusty conditions. A well-designed and insulated house with proper ventilation equipment and controls will work around the clock to achieve desired thermoneutral zone. See, basically this point is very important because what it effectively is trying to say is, earlier what I said was, okay, you need air exchange. You need to exchange the entire air in the house, let us say at a speed of 3.5 meters per second. But there is a limitation, there's an upper limit to that. If you take this, you can't just keep increasing the amount of air that you are increasing inside the house, because there is an upper ceiling to everything. If you reach a point where you create a very uncomfortable draft inside the house, the chickens are again going to have respiratory issues. One of the diseases like ascites is also caused because of a lot of dusty environment. They have lung infections. So this can't just keep going up and up and up. The limitation is there. I would say anything more than 4 meters per second is a problem. So we have to make sure that the air velocity is capped at a certain velocity, and beyond that you have to use other factors to make sure that the birds are very, very comfortable. You know, EC. So what are the limitations and what is the principle of evaporative cooling? So basically evaporative cooling is to reduce temperature in a house by utilizing heat in the ambient air to evaporate water on the cooling pads. So basically we have cooling pads in which we put water on them, and then air passes through this, which is a colder air. So that is going to give you a cool breeze inside the house. The drier the air that is outside, more water is going to be evaporated, as we saw in the principles of relative humidity, and thus more heat can be utilized from the incoming air to evaporate more water. Thus temperature reduction is going to be significantly higher in drier conditions for EC houses, for using cooling pads. When the ambient air is already humid, so in a hot and humid country like ours, the less water is evaporated because the humidity inside the air is already reaching its saturation point. So in this process, the effectiveness of cooling pads goes down. And in the process of evaporative cooling, humidity of incoming air, if you keep putting water on the cooling pads, you are just going to increase the relative humidity inside the house. Now, this is where the sweating and the panting part comes in, because the birds can't sweat. The way they deal with humidity becomes a major issue. So you have to always ensure that humidity inside a poultry house, not just temperature. We focus sometimes too much on temperature, but we have to give special focus on humidity also. When outside humidity is high, let us say more than 70% relative humidity, the capacity of the house, the capacity to reduce house temperature using evaporative cooling starts diminishing. Up to 70%, an evaporative cooling system, 60 to 70%, it works wonderfully. Above 70, the effectiveness starts going down. So in the next chart, as you can see, in the next page I'll show you, if the temperature is 32 degrees and the humidity is 30%, the house temperature can be reduced to 22.6 degrees Celsius, with the humidity of incoming air increasing to 75% RH. But as the outside humidity increases to 60%, the reduction is possible to only 27.3%. Now there is a chart that I'll show you after this, which will explain this in detail. This is a standard chart of the limitations of an evaporative cooling system. No matter what you do, you cannot achieve standards beyond this chart. If anyone is telling you that I can achieve 22 degrees or 24 degrees Celsius when my humidity outside is 80% and my temperature is 40 degrees Celsius, that is not true. By using evaporative cooling system, you can never achieve this. So this is very simple. As you can see, this is the relative humidity or the humidity outside and the temperature below. So as you can see, when the temperature is around 32 degrees Celsius and the humidity is 90%, for a well-designed house, you can achieve about 31.1 or 30.6. So you can only have about 2 degrees of heat that you can reduce inside the poultry house. So this is the challenge of an evaporative cooling system. And once we understand this, it becomes very easy for us to use the existing parameters to give the birds a comfortable environment inside the poultry house. So when the humidity is in the ambient air, incoming air is already high, then the solution to reduce temperature inside the house by evaporative cooling pad has its limitations. If we further add humidity to air, it will produce adverse effect on the birds. In such hot and humid condition, the only solution is to increase air exchange. But again, as we know, there's a limitation to it. So as I say, 3.5 meters per second is probably the limitation of what we can do in this. We can't go further beyond that. The bird comfort in hot, humid condition can only be enhanced by ensuring entry of fresh air through the building, and not only through cooling pad area, but this can be achieved when inlets will open in set percentage and air enters in house in 2 ways. One through cooling pad and another through air inlet. So this is where we have to understand that the controller needs to be given extra parameters in hot and humid conditions, what we at Gartech call as turbo tunnel ventilation. So not just cooling pads and fans, but tunnel inlets, air inlets, and correct opening of them, which should also be remotely controlled, is very, very important. The amount of air coming in has to be increased without increasing the air velocity. This is the critical part for the correct environmental control systems. So some of the points to note, as we are running short on time, some of the points to note are cooling pads should not be used at temperatures below 28, 29, and when the humidity is 85% plus. It is going to have an adverse effect. So this is one issue. If you are using fogging, anything above relative humidity of 75%, also fogging system is not going to work, so should not use that. Generally in the night time, it's not advisable to use cooling pads because it's only going to increase the humidity because absorption is not going to happen properly. One more thing that is very important is this slide at the end. Consider house temperatures 30 degrees Celsius with 84% humidity, and consider 31 degrees at 80% humidity. In case 2, when the temperature is more, the birds are actually going to be more comfortable than case 1, although the temperature is less, because the humidity in case 2 is lower. For birds, humidity is slightly more important than temperature, and that is something that we have to always remember. Humidity is a bigger enemy than temperature. So this is just, what is the solution? If you don't want to do all of this, we can put an AC in the house, but AC is not practical. This is a simple chart. Effectively, I will not go through all the details, but just to let you know, for 50,000 birds, commercial layer house, if you put an AC, you will end up spending around 22,000 rupees per hour to get what you need inside the house. And thus, AC is something that is not practical. So we are left with evaporative cooling and no other option but again, a well-designed house, a well-insulated house, not just cooling pads and fans, but a complete system. Turbo tunnel ventilation is the key, where air exchange without increasing the amount of velocity inside the house is the way to go if you want to achieve good results in an EC house. This is the conclusion for what we want to talk about. Ensure air velocity remains, I would say, over 2.5 for optimal bird comfort. Avoid using cooling pads when humidity is high. Use tunnel ventilation in combination with air inlets and tunnel inlets. Maintain RH at around 65% if you can, and temperatures if you can. So this is the end of it, and thank you. If you have any questions, we'll be happy to answer.